Okay, now we have this equation. Okay, and we see on the right-hand side we don't have 0 anymore. So how are we going to deal with that? Well, the first thing we do is we get a solution of this left-hand side equal to 0. That is, we solve the homogeneous equation. We just get rid of that, make it all 0, and see what we get. Okay, and clearly then we get these solutions, e to the negative 2t and e to the negative 3t. Agree? Mm-hmm. And now we use our trial solution to get this. We plug it in to the left-hand side, and we end up with 2t squared. The question is, what kind of function would we plug in? That almost looks like some sides of y, so let's make it a little clearer. Okay, well, what kind of function? Okay, well, the suggestion we got was, well, you're going to have a square, okay, in order to get a square. Well, that's true because if you don't have at least a squared term, well, your first and second derivatives are going to give you 0 if you have a power less than 2, right? And your third term would be a power less than 2, so you're not going to get a second power. Okay, so I'm going to say y trial must be of at least degree 2. Anything less is never going to give you a degree 2 term. Okay? Can't be of degree greater than 2, because if it's of degree greater than 2, well, these would both have a lesser degree than whatever the degree is, right? But this one would have that degree. So if it was, for example, of degree 3, this would be a degree 1, this would be a degree 2, and this would be of degree 3. Well, you can't have a degree 3, okay? And these aren't going to interfere with the fact that this gives you degree 3, right? So the left-hand side would be of the same degree. I could have just said originally, whatever degree you use, these derivatives are going to give you an expression of that degree. Since you only have degree 2 here, you can't have a degree bigger than 2. You could, you could use a 12th degree polynomial. It'd be overkill, but the result would tell you clearly that every degree over 2 has coefficient 0. Okay? So it'd be pointless to go to that much trouble. So now, we're going to say, okay, what if we just use t squared? Well, if we just use some multiple of t squared, like ct squared, right? Then you would get 2c here. And you would get 5tc here. And you would get 6ct squared here. Well, you're going to have a degree 0 from this, a degree 1 from this, and a degree 2 from this, but you've only got a degree 2. You got to do something about the multiple of t that you get here and the constant number you get here. So the solution, and it's not too hard to understand why, especially after you've worked a couple of these. So I'm going to say t squared alone yields terms of degree 0, 1, and 2. And that can't equal just t squared. But I don't want to use C1, C2, C3. We've used A, B, and C in solving the quadratic, but We're done with that. So I'm going to use AT squared plus BT plus C. Okay? And we can see that this is going to give you a mix of first degree terms and constant terms, in addition to a T squared term. Okay? So, let's plug that in and see what we get and see what we conclude.